Okay, so today we are getting you ready for the big test. This is probability B. Honestly, this will be your toughest test of the year. I'm not kidding. But that doesn't mean you can't get an A. That really doesn't mean that. You can get an A on this test, but there's so many complicated things in probability. Honestly, I could give this test, the test that you're about to take tomorrow, to if I'm allowed to pick which ones, I could give it to probably 3 math teachers, and they would probably get a C on the test because they haven't had this recently, and this stuff is tough. Now, you've done it recently, so I think you'll rise to the occasion. But my point, you should take this seriously. You really got to focus. All right. So here are some tools for probability. One is blanks. Here's how you'd use blanks. Let's say that we have a number, and that if that's a 4-digit number, what's the biggest it could be? Don't overthink this. Yes, you can repeat. 9999. Yeah, good. Okay. Then if I had you pick a random 4-digit number, what's the probability that it would be above 3,000? I should say 3,000 or above. If I had you pick a random 4-digit number, what's the probability it would be 3,000 or more? All right. Well, first of all, I said probability. That means it's what I want over what's possible. So I'm going to put what I want up there and what's possible down here. What are all the possible numbers a kid could pick? Well, that one would be 9 times 9 times 9 times 9. Notice I didn't ever say the numbers can't repeat. What if I had said that? Then it'd be 9 times 8 times 7 times 6. Yes? Wouldn't it be 10 because it goes? You got me. Very good. It should be 10. 10, 10, 10, 10. I forgot that it's 0 through 9. That's a classic mistake. 0 through 9 is 10 numbers. 10 times 10 times 10 times 10. Thank you. And then, what's the ones that I want? What I want is at least 3,000. That means that this first number could not be a 0, a 1, or a 2. So think of it this way. Out of 10 numbers, I got to throw out 0, 1, and 2, which leaves how many left? 7 choices for this. For the second digit, again, numbers can repeat. So I can have all 10 choices. And then, since that's divided by that, look at the nice canceling I can do. Boom, 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 and I have 7 tenths. All right, blanks are really handy. I'll give you another example of when you'd use the blanks as a tool in this probability test. You have 8 people, but of the 8 people, these are like all friends at graduation, and they want to pile into one picture. Okay, but they take us second, and they're like, you know what? Let's put the 2 tallest people in the middle. So there's 2 really tall people, and the rest of the people are kind of normal height. Okay, so if I have to put them in the middle, where is the middle? Oh, these 2. And how many choices do I have then? 2. So it's 2 times 2, true or false? No, false, because you can't have the same person. So if once you've picked one of them, then you don't have 2 choices left, you only have 1. And then there was 8 people, so now we're down to 6, 5, 4, 3, 2, 1. It all multiplies. Yeah, multiply choices. That was one of the themes. Okay. Next kind of tool that I want to make sure you know how to use is CC. If it was a CC over C, that would be for probability. This is just how many ways. If you multiply things, it's because you want this and that to happen. If I wanted this or that to happen, I would add. But I'm multiplying in this one. I want something and something to happen. All right, so out of this room right this minute, I have 1, 2, 3, 4, 5, 6, 7 boys. I have 7 boys. And I have 1, 2, 3, 4, 5, 6, 7 girls. I didn't expect that. I'm going to cheat and say we have 6 girls. Sorry. The reason is otherwise these would be too similar, and it'd be a little more confusing, actually. Let's say that I wanted to pick groups of 3 people, but I'm going to make it 2 girls and 1 guy. How many different groups could I have that would have 2 girls and 1 guy? So remember, if it's CC, that won't give you a probability. That'll give you a how many ways can I thing. And then I would start with this being boys and this being girls, and it wouldn't matter. You could switch them. It wouldn't matter because multiply is commutative. I'm going to pause for a second. Multiplication is commutative, I should have said. Okay. Dice of Destiny. You're going to be obviously a lot of empty spots, so there's going to be certain holes. It's row 5. 1, 2, 3, 4, 5. Ha! That makes it you. All right. It's only you. So tell me, how many boys, and then I'm choosing how many. So 7, C, 1. And then how many girls and how many are you choosing? There you go. And you multiply this because it's this and that. Yes. Okay. Next, we have to be able to make this into a kind of probability question. Why don't you just leave that on your screen and then modify it in this way? If I picked 3 people at random, what's the probability it would be 1 boy and 2 girls? If I picked 3 random people, what's the probability it would be 1 boy and 2 girls? The reason I said you could just leave it on the screen is because now you can just divide by how many people were there total? 13. See, how many people are you picking out? 3. And that makes it a probability because now I'm dividing by what was possible. Anytime you have subgroups like boys and girls or diamonds and hearts, that's the kind of question that you can do with the CC over C. Let's do one more of those. This one's going to be pizza. And let's see if you can figure out which kind of a tool you should use for this. I have 7 kinds of meat and 10 kinds of vegetables. How many 2-topping pizzas can I have where you get 1 meat and 1 veggie? 7 meats, 10 veggies. How many 2-topping where you have 1 meat and notice I said 1 veggie? You should have said that is not a CC over C. Why? It's not a probability. It's a how many different ways is there? And so it's a CC, and it was 7 meats choosing 1, and it was 10 veggies choosing 1. 7C1, 10C1. Can you do that in your head quick? 70. Very good. Okay. Next. Let's say out of the approximately 14 kids that are in here right now, so I'll say 14 this time. Let's say I take you all out to the parking lot and we race. If we keep track of only, just because it's complicated to keep track of exactly a whole bunch of places, but I can get first, second, and third. How many different ways could that happen? There's 14 of you. We're having a big race in the parking lot. I only care about first, second, and third. How many different ways? All right, so as you're doing this, you should be thinking, is it a C or is it a P? And which one was it? It was a P because it said first, second, and third, and that's way different if you got second than getting first. Okay, so the order mattered. So you should have said 14 P, and then how many am I going to take out? I'm only going to keep track of 3 places. 14P3, raise your hand if you had that one right. Awesome. Now write out what it is if you had to do it without a calculator. Oh. And I know some of you are like, well, Mr. Server, I'm always going to use the calculator. Not if I change it to 14PC. You couldn't use your calculator, could you? So you need to know how to do this without the calculator. And the main reason I'm focusing on this is because I've seen this on the ACT before, where they ask you with some variables to say, oh, so it'd be this factorial over that factorial. Remember this? How many of you knew that there's a 14 factorial on the top? Raise your hand if you did. Okay, awesome. Then it's 14 minus 3, which is 9 factorial. Nope, it's not. What is it? 11 factorial. And then is there an extra 3 factorial in there? No. That's if it had been 14C3. That would have been 14 factorial over 11 factorial with an extra C. There's one of these. It's a C problem, so you need an extra one of those. And that makes these answers smaller because you're dividing by more. And shouldn't P's be big answers? Yes, I've tried to impress upon you by talking about getting on a bus out in the parking lot and how rearranging it would take us the rest of our lives. It's just an insane idea. Just rearranging into all the possible seats on the bus would take the rest of your life. It's crazy talk, but it's true. Actually, there's a small enough number of us in here that we might be able to actually complete it. But back when there was 30 kids in here, rest of your life. Okay, so this one, final answer, is 14 times 13 times 12. What? Where'd the 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 go? They got canceled. Because there's one on the top, one on the bottom. So final answer would be this. Couldn't you have done it with 3 blanks? You could have. Remember, there was 3 people in a race. Well, no, there was 14 people in a race, but only 3 keeping track. So we go, there's 14 ways you can have first place, 13, 12. Look at that, they're the same thing. They're different tools, but they can get you the same answer sometimes. If I had to only pick one, blanks are really powerful because you can be more like, you do weirder problems, like we only have one choice for the first spot. As soon as you do that, it makes it way harder to try to do a P. All right. Next one, books on a shelf. It's a classic thing. It's going to happen to you for the rest of your life. May not be books. It might be, I don't know, copies of magazine, or it could be devices on a shelf. It could be like, you know, I've got all these things stacked on my shelf. Maybe someday you'll just have less things because, like, you have everything digitally on your iPad. You don't even need, like, mail. Will there be a day when we don't even have mail anymore? Probably. I think it'll probably be all digital someday. I mean, there'll still be some, people will want to write notes to each other, I think, still. You know, there'll be occasional little pieces of mail, only for, like, making something intentional. All right. Next one I want to try is the C with the 2 parentheses after it. This kind goes like this. You are out playing soccer, and you are in a game where they have, what's that called when it's a tie and then they have to shoot a bunch at the end to, like, see who wins? They shoot out. Okay. And what type of, when you do a shootout and you put the ball out there, that's called a what kick? A free kick? Is it penalty kicks? When you do a shootout, it's called penalty kicks. All right. Okay. So let's say this kid's really good. He's got 9 out of 10 so far this season. He's therefore got a 90% average on his penalty kicks. Okay. He's really good at this. He gets 3 kicks. What's the probability he makes at least 2 out of the 3 kicks? Hint, start with 2 out of the 3. And then figure out, oh, what would be even better than that? Did you realize this is 90 and this is 10? And you got 3 kicks and you wanted to make 2? That would be slightly wrong because this is the answer for just 2, and I said at least 2. Then you got to think 2 or what? 3. Then this would be 3, and this would be, wait a minute, 2, 1, 3, and 0. There we go. You get both decimals. Would you, sir, tell me the first one when you got it? 0.243. Can anybody verify that the top one is 0.243? All right, getting 3 people verifying that. That's good. And the other answer, in the back, Miss C. What'd you get for the second answer? Okay, I'll speed it up for you. Just do that, because the other ones just equal 1. Can you tell me what 0.9 to the third is? Seven what? All right. Why was it more likely that he'd make 3 than making 2? Does that make sense in the real world? Yeah, because he's really good. He gets 90% of his kicks in. It's very likely he's going to get 3. Do you get 2 or 3 would be this and this together, and that's a very high percentage. 97.2%, something like that. Okay. All right. That's how you use or, if it's this or this. All right. We're going to change the problem, and I'm going to see if you remember this kind. I've got a weighted coin, and I try it 1,000 times just to see if it's really going to come up heads more, and it does. It comes up 552 times out of 1,000 flips. It comes up 552. That is pretty significant. You did it 1,000 times, and it's way more than half. So it's a weighted coin that favors heads. Here's my question. Out of 3 flips, what's the probability that I'd never get a heads? Out of 3 flips, what's the probability I would never get a heads? Make sure I added that right. I think I did. Is that right? Is that what you guys got? Okay. And then, how many tries do I have? 3. And how many did I want to get of the heads? 0. And then that would be 0, and that would be a 3. Can you tell me what that came out to be, sir? Can anybody verify the 091? Yes? Okay. GJ, if I said, what's the probability he'll make at least 1? You could go do 1 or 2 or 3. Add them all up because they're ors. But what's the probability you can do it in your head though, can't you? What's the probability he will not miss? As in he will make? No, that's not the right answer. I'm sorry, I said it wrong. I'll say it again. What's the probability he'll make at least 1 of his shots? That's different than not miss. He'll make at least 1. Okay, let's do it to 3 decimal places so we can make sure that you're right. 9 Is it 909? I think. And that would round to 91%. Yes? Well, if we go to 3 decimal places, frankly, I'm trusting a different kid, so I got a couple of people to verify it. Can you use your calculator once and type in 0.448 to the third and tell me what it says? 0.0899. Okay. Ooh, that was a problem. If that was 0.0899, it would round to 0.09, but it would not round to 0.91. Think of it this way. You're right. That's an 89. What's the next number up from that? 90. So you're right. This should have been a 0. And I get totally somebody saying, but there's a 9 after it. How can it be a 0 there? Because 89 compared to 90, we did already round it up. Thank you for catching that. And therefore, if that's 0.09, as in 9% chance he'll get no heads, then it's a 91% or 0.91 that he will get at least 1. So it's 1 minus that. So many things to know. Okay. Next kind I want to talk about is CC over C with cards. You get dealt 5 cards. Out of 52. The question is, what's the probability you get 4 jacks or 4 queens? Now, you might be thinking, but Mr. Server, you said we got 5 cards, and you're saying I got 4 jacks. Yeah, you got 4 jacks and 1 other card. You got to factor that in. All right, this is a tough one. If you can't do that, just try to figure out the first part, probability of 4 jacks. And remember, the tool, CC over C. Pause for a second and try that. Okay. Here's 4 jacks. 4 jacks, and I want all 4. But I also need 48 other cards. Choose 1. All over 52C5. That's just the jacks. If that's all you could manage, that's not bad. That's the probability of getting 4 jacks and 1 other card. Or means add, right? Now, some of you are going to just keep it all the same denominator on the bottom, and that's fine. But I'm just going to show you it is 2 separate things. You just happen to be able to add the denominators because it's a common denominator. Okay, and then the 4 queens thing, it's identical. Because 4C4, we can't tell that those are jacks versus queens. And then it's 48 other cards, choose 1. And so couldn't I, instead of adding 2 identical things, just said it was 2 of the first thing? True. Don't have to do it that way, but okay. Do we need to practice more like that? How many of you got that one right? That's a lot of you. Okay, I think we should probably be good on that one then. All right, next let's talk about warranties and expected value. So, you all have an iPad in front of you, right? Do you get that at the beginning of the year they offered you an option to pay something ahead of time, and then if your iPad screen cracks, they would fix it for you? I'm pretty sure they gave you that option, didn't they? Okay. Does anybody know how much it was? I think it was like 50, wasn't it? I think it was 50 bucks. Okay. So the school offered basically a little warranty plan. And by the end of the year, it's either going to work or it's going to break. If everybody knew their screen was going to break, it would only be smart to buy the warranty because, you know, $50 is cheaper than fixing an iPad. But this is how insurance works. You don't know if you're going to have the accident or not. So if everybody actually had to replace theirs, the school would have lost a ton of money on that. They would have charged more if they knew everybody was going to replace their iPad. So anyway, that's how insurance works. Let's say, I just want to know, out of all of you guys, if you count to last year at this time, you've had an iPad the whole time. I know it's clean one school year. It's part of last year and then all of this year. The question is, how many of you had it where you broke a screen in that time period? Nobody in here broke a screen. Okay. So it must be pretty rare. Or you're the responsible ones, which is possible. But are you saying that the people who take AP Human Geo are irresponsible people? Okay, anyways. I get what you're saying. What you're saying is in an honors class, you might have fewer broken in an honors class. It's true. I don't know. I'm not sure you're right, but it could be. All right. So how about this? I'm going to give you some numbers. Let's say that 5% of them break and 95% of them work. Therefore, if you paid $50 for this warranty and it saves you, let's say you didn't buy the warranty and you had to fix the screen. Does anybody have a number that they know is true for fixing an iPad? Otherwise, I'll make up one. Fixing an iPad screen. Anybody know? I can buy that. Let's say it's $150 is what it's going to save you. So we're going to say that if your iPad works, you get nothing. But if it breaks, you're going to get a value of $150 because you don't have to pay for fixing the iPad. Now, what haven't I factored in yet? What's the one number I haven't used? I said it, but I haven't used it yet. The 50. You wait till the very end and you subtract that off. Okay, so first what we get to find out is what was this actually worth? That times that, this is P times A, and then we add them. So that makes 0. And then this one times this one. I'm going to pause for a second while we figure that one out. And that costs $7.50. Or, sorry, that's what that's worth. And then it's P times A, then add. I add these two together, it's worth $7.50. If the warranty's only worth $7.50, what if you paid $50 for it? Well, then you'd theoretically lose money. Now, I will say, I'm not trying to say that our school's warranty is a ripoff. I'm not saying that at all. I totally made this up. I don't know if it's really 5% or 50%. If it's 50%, then it's a whole different deal, and actually buying the warranty makes you money on average. But if you don't remember to put in this minus 50, you would have thought it was worth $7.50, and that's your expected value. It's not. Your expected value is to lose $42.50. And if you lose $42.50, then if they ask the question the other way, how much will the school make on you? $42.50. Okay. And again, I totally baked this number, but the rest of it's pretty accurate. All right. So given that you just saw how that worked, we're going to try to do it one more time, except with a much higher breakage rate. Would you now assume that there's a 40% chance that you will crack your screen? 40% chance you'll crack the screen. It still saves you $150 of a repair cost. The warranty costs $50. What's your expected value? I'll pause for a second while you give this one a try. Always start with works, breaks. Pause, we try that one. Okay, so 60% chance it works, 40% that it breaks. Nice, that's the probability. What's the amounts? What do you get if it works? What do you get if it breaks? A value of $150 that repair you won't have to pay for. And then you multiply. And the reason on the key that they have a negative number here. What? Why would they have a negative number there? Because they're making the argument, if you had your iPad work, then you wasted negative, as in you spent money on a warranty you didn't need. But I don't think that that's the smart place to put that. So I don't do it that way, and I hope you don't either. Then this times this, and I think that comes out to $60. Is that correct? Okay. And now P times A, then add them up. It was worth $60. What is the one thing I have not factored in yet? The $50 cost. And I now have a $10 positive number. What does that mean? That's called the expected value. And that means on average, a kid that buys the warranty makes money. And you can kind of judge that and say, well, then that's smart. I will even argue if it's a small negative amount, if you have the insurance, you do get something out of that. You have peace of mind. Like right now, I just realized that my iPhone, I don't have the coverage for it anymore because I switched carriers. I was with one company and I had the insurance there, and I switched to a different carrier and I didn't put the insurance on it. So now I'm feeling like my iPad, like, oh geez, I don't want to drop it. If I drop my phone, the iPhone X is like $300 or maybe it's even more to repair. And I'm a little bit scared, so I'm thinking maybe I should just go get the insurance on it. Because then I'll have, why? Do I want them to make money on me? No, I want peace of mind. And because I don't have to worry then if I drop my phone, it won't cost me a ton of money. Yes? Wow. Okay. All right. So that's an example of expected value. I want to do one more expected value kind of question. I'm going to pause for a second while I cook one up. Actually, I decided that I don't think we need more on the expected value. Just remember it's P times A, then add. You always take the probability of the situation, the amount you get if that happens, and then add them all up. All right. I am going to instead spend our last minute or two talking about something like this. Let's say this is the drop zone, and you are supposed to hit this circle right here when you are coming in on your parachute, okay? And if you land outside that, you don't get the bonus, but if you do land inside that, then you get special jump wings. You know, you get the little jump wings that have like the little flames coming off of them or something. So my son got the jump wings for going in the Air Force Academy and completing 5 jumps solo. You can't have anybody, you know, on your back or anything. That's called tandem. 5 solo jumps and surviving, and you get the wings. Okay, so I'm saying, what if you got special wings for being able to land inside a little target like this? It'd be harder to do for sure. So what do you need to know? Find the probability you'll hit it. Well, first of all, this isn't fair because if you're aiming for it, it depends on your skill level whether you'll hit it or not. You get what I'm saying? So let's say it's just random, and whoever happens to land in that circle, they don't know that they're going to get any prize or anything, so they just find out how many people happen to land in the circle. Do you get what I mean? I got to make this random, otherwise it isn't really probability. Okay, so then I'm going to say that this is 10 feet across, and I'm going to say that this is 100 feet in both directions. Yeah, that looks like 120. I'll make it 120 and 110. Find the probability you land in the red circle. And probability always boils down to what you want over what's possible. And it's wanted outcomes over possible outcomes. What were all the possible outcomes? That times that. When you multiply by 100, you add 2 zeros. 120, 0, 0. There's 12,000 square feet out there that you could have landed on. How many are the ones you want? What you want, those, it's pi r squared. So a mistake answer that's really common is 100 pi. They didn't use the radius, did they? If you had 100 pi, you'd be like, oh crap. Okay, so it's actually 5 squared is 25, so it should be 25 pi over 12,000. And some people get confused by that pi in there. It's just a number. It's 3.14. On the test, you can use the pi button if necessary. And then you divide those two and get an answer. Did you already divide those two? Would you please take 25 times by 3.14. We'll just keep your life a little simpler than finding the pi button. And then divide by 12,000. The suspense is killing me. Awesome. If you had to say that in real person words, about what % chance do you have that you would have landed in the circle? 0.65%. Yeah. So that's less than 1%. Would it round to 1%? Yes, it would, because it's more than halfway to 1%. So it would be rounded to 1% chance that you would get the special flaming wings, which really wouldn't make any sense because if it isn't a probability question, it's a skill question. Okay, so that's called area types of probabilities. Now, you just have to remember where to use these tools. I'm going to remind you one more time. What are blanks good for? They could do permutations, but better because you can make conditional. Like, this person has to be in front, so you only have one choice here. And then you have 6 other kids that are going to be chosen from. Now, that kind of question. So blanks are good. How about CC? If you have CC, is that a probability? No. That's a how many ways can you? And that's subgroups, like I got my veggies and I got my meats. Okay, or I got my boys and I got the girls. And you multiply those. Okay? How about CC over C? Is that a probability? Yes, and that's when you have subgroups, like I want this many boys and this many girls out of this many people total. And then there was this kind, and that's called a binomial probability. And I guarantee you that one can't be right. Why? What about the 3 and the 7? What should they add up to? They should not add up to 4. They should add up to 5. Okay, so this could be a 2, and then that'd be okay. That's an example of a binomial. And a complicated binomial would be something like at least makes 1 free throw. And then that's just saying not 0. All right. Okay, we've covered everything. Now, tonight's homework is more important than average by far. I'm saying it out of a probable total of around 20 tests this year. This may be your hardest one. Now, it does depend. Some kids rock probability. They're just good at it naturally, and others just struggle with it. On average, our test grade probably will be lower on this one than most other tests. So study tonight by doing all the practice problems. And I will remind you in class, okay, Dropbox them now. So make sure you do the whole worksheet. And it'll be Dropboxed when we take the test tomorrow. Any last questions? If you happen to be one of the kids that's gone for an AP test today and you don't want to take the test tomorrow, it is okay to delay it. I will say unless you study, you'd be better off, since you've watched to the end of the video to hear this, I would just take it tomorrow if I were you. But if you want to, because you're gone the day before, I do give kids the option to skip it and take it later. But then you'll have to go restudy again. Okay, and that's all I have for you for today.